Alright, so these are still problems with probability and combinations and permutations. Here's the difference though. If you read either of these questions, you'll notice at the end they're no longer asking us what's the probability that exactly 5 buttons are black or exactly 3 fireworks are blue. They're using this word. They're saying at least. Okay, and that's going to be important in terms of how we figure this out. So let's read this first and we'll figure out how to do it. Technician is setting off fireworks. You have 12 fireworks left. 7 of them are blue, and it looks like the other 5 are going to be red. Okay, it says he launches 5 randomly. What's the chance that at least 2 are blue? So let's think about this first of all. At least 2. Okay, so remember he's launching 5 of them. At least 2 could mean that 2 of them are blue, or it could mean 3 of them are blue, or it could mean 4, or it could mean 5. Okay, and I'm going to write the word or there because you might remember from the past that the word or in probability means that we're supposed to add these. Okay, so what this is going to end up equaling here is we have to take, it looks like 4 probabilities, the probability of exactly 2, the probability of exactly 3, exactly 4, exactly 5. We have to take 4 of those probabilities and add them. Okay, there is actually an easier way to do this though, so you might be put off by that and say, well, that's a lot of stuff to add. Okay, and we can do it this way too. At least 2. Here's my question for you. What is the opposite, or another way of saying the opposite is, what is the complement of at least 2? What's the opposite of 2 or more? And the answer is less than 2. It could be 0 or 1. So there's 2 ways you can do this problem. I'm going to show you both ways. I'm going to show you the long way for number 13, and I'll show you the shortcut for number 14, just so you have them both and you can decide what you want to do. Alright, so it's the same setup as always, it's just now we have a lot more probabilities than normal. Okay, so it's going to be, we're doing this the long way, by the way, this time. So that's adding probability of 2 or 3 or 4 or 5. Alright, so let's figure this out. So we have how many total fireworks? We have 12, and we are choosing to launch 5 of them. So 12 choose 5 is going to be what could happen. There's 12 choose 5 ways that we could set off 5 out of 12 fireworks. Okay. Then let's start with, remember we're doing the probability of at least 2. So let's start with the probability of exactly 2. So the probability of exactly 2, well that's going to be, we want at least 2 blue. So let me write this. So this will be 2 blue, this one will be 3, that's going to be 4, that's going to be 5. And remember, every time we're setting off 5 total. So if I set 2 blue, that means 3 red. If I set 3 blue, that means 2 red, because we're trying to get it to add up to 5. 4 blue would be 1 red, and 5 blue would mean no red at all. Alright, so let's go down the line. So we have 7 blue ones, and in the first scenario we are choosing 2. Now we have 7 blue ones. In the next scenario we're choosing 3. This will be 7 choose 4. This is 7 choose 5. Okay, then we have times. Here we have 5 total reds, so we could do 5 choose 3 reds here, 5 choose 2 reds here, 5 choose 1 red here, and 5 choose 0. Okay, and actually 5 choose 0 is going to wind up equaling, should equal 0 if you actually check that. Actually, let me just double check. I don't want to give you the wrong information. No, it's actually 1. I'm sorry. So anything choose 0 is 1. How many ways are there to choose 0 red fireworks? There's only one way to do that. You could just choose none of them. So that number, anything choose 0, just equals 1. Okay, so what you'd have to do is put this in a calculator, put that in a calculator, that in a calculator, that in a calculator. You could always store each of these values too. I think we talked about that earlier in the year. So let's suppose I do this one. I could store that as alpha A, let's say. And then you could store this one as B and C, and so on, and then you could take each one of those 4 and just add A plus B plus C plus D. Or you don't have to store, you can just keep it individual like that. But when you do that, when you add those 4 together, you should wind up getting, if I could get this to work right here, you should wind up getting, whoops, sorry, the page went all over the place there. So let me move that back. I don't know if you can see that anymore, so let me try to fix that for you. Should get 95.45. And I was just double checking that on my own calculator, and it does turn out to be correct. So I encourage you to try it and pause the video and see if you can attempt number 14. It's going to be the same exact type of setup. Okay. And I said I would show you the shortcut way using the complement. So here's what we want to remember about the complement. just from a while back. So let's suppose I told you that the event we're dealing with is it's snowing outside. And I told you that the probability that it's snowing is, I'm just going to make something up, let's say the probability that snowing is 95%. It's January, it's a cold day, it looks like it's going to snow, okay? Complement of snowing, the complement of the event snowing is just not snowing. Doesn't mean sunny, doesn't mean rainy, it means we have to include everything besides snowing, which would be not snowing. And if the probability of snowing is 95%, my question for you is what's the chances not snowing? And the answer is 5%. These numbers have to add up to 100. So in this problem that we just did, we could have found the complement of at least 2. And that's what we'll do right now. We could find the complement of at least 2. The only thing you have to remember is at the end of the problem, you're going to have to take whatever you get and subtract it from 100%. And a lot of people forget to do that. Okay, so if you had done on this problem right here, if you had done it the complement method, which I'll show you right now, you would have gotten 4.54%, and 100 minus that number would get you the 95. So let's try that with this gardening example. Gardener has 12 identical looking tulips. 6 will produce yellow, 6 will be pink. Okay, so you have 12 total, and you are selecting 6 of them. So that means, and let's deal with at least 2. At least 2, the complement of at least 2 would be 0 or 1. Okay, so this is considerably shorter because we have to have the probability of 0 or, which means plus, the probability of 1. So let's do that right now. Okay, and then this is going to be a lot shorter than the other one. All right, so we have 12 total things, and we are choosing 6 of them. There's 12 choose 6 things that could happen here. That's what could happen. Okay, what do we want to happen? We want to get, in this case, we want 0 yellow, and in this case, we want 1 yellow. Okay, and if we get 0 yellow, we're going to have, remember we're picking 6 total plants here, so I guess I don't want to put this in yellow because you won't be able to see it. I'll put it in orange instead because that will be visible against the white background. So 0 yellow and 1 yellow, and then if we're getting 6 total, that means 0 yellow would be 6 pink because that's how you get 6 total. And if we had 1 yellow, we would have 5 pink. All right, so let's figure this out. So 0 yellow, how many total yellow are there? There are 6 yellows, and in this first example, we're choosing 0 of them, which you may remember when you put that in a calculator. Anything choose 0 is 1. And then if we are doing 12 total and 6 of them are yellow, that means 6 must be pink. And in this case, we're choosing 6 of them. 6 choose 6. Second example, we have 1 yellow. Okay, so it's going to be 6 choose 1. And remember, this number and this number right here have to add up to 6. That must mean I have 5 pink. And again, it's still 6 choose pink. So you put that in a calculator right there. And what you will get is, well, I'll show you the final answer. Okay, and I'll tell you how you get this answer. If you put this in a calculator right here, what you should get is about 4.004, roughly, something like that. If you do 100 minus that number, that will take you to this answer right here. So that is a little bit of a shorter and faster way to do this using the complement.